Well, welcome to my extremely messy office slash workshop here. I just thought I'd quickly go over my new foam combat wing. You might have seen me flying this one on a recent video, sneak peek video. It's similar in design to the corrugated plastic wing that you can see over here, except that it has the one stabilizer and it's made of foam as the obvious difference. So I just thought I'd quickly go over. I'm not going to do a full build video. I don't really think that there's anything groundbreaking here, but I thought I'd go over at least the dimensions for this wing. So hopefully I've got another camera, you can see here, mounted on my head. Hopefully that one's going to capture what I need it to capture, and I can get rid of this handheld one for the time being. So you can see I've got a second one that I'm building right now. In the other video, in the flight video, I was using this 2206 motor. Didn't quite have enough thrust, so this motor is a 2150 kV motor. It's the one that goes on the AXN floater, the Cloudsfly. So that should have plenty of push for this wing. So okay, I'll just go over the dimensions quickly. From side to side, it's 30 inches. Okay, so the full width is 30 inches. From top to bottom, it's 23 inches. Now this one's important. Across the top, whoops, here, let me just swap that over. Across the top, it's 4 inches, where the plans for this one here say 3 inches. So 4 inches across the top here. So what that leaves is it leaves 13 inches for, here, let me just put that down, 13 inches for this span, if you were to go that way, and then 13 inches for that span, making a total of 30 inches. So to go back for the opening, it's 8 inches back until the opening, and then another 2 inches for the opening itself, and the opening is 10 inches wide. So you notice that there's a top piece here that goes on the bottom piece. So that top piece is the 10-inch gap, and then back for a full, what is it, about 10 inches. And the width of it, here I have 13 inches. So you can see how it is there. Now on the new one that I built, I actually put this top piece back another 2 inches further. So if you were looking at this one, it would be 2 inches more this way. I don't need it for the stability. It's more in line with what my original designs were. So in addition to what you've just seen there, you can see, put that down, you see here and here, those are fiberglass rods, and they come right up to the center. You can't see because it's underneath the second foam piece. They come right up to basically touch each other here and go down on the sides. And you can see I've done the same thing with this one, except these ones are a little bit more parallel with the side piece, about 2 inches in. And then I have another carbon fiber, a thin carbon fiber. It could just as easily be a fiberglass rod, but I just did a thin carbon fiber where I just do a slit in the foam. I just kind of draw a slit in the foam, shove that in, and then some Gorilla Glue on it to hold it in place. So what these do, the combination of those three, the A-frame, it gives us a nice rigidity in the air, and it's going to hopefully help it if I have crashes. So what else to talk about here? I guess just that I kind of beveled this front end, top and bottom, and I wrap it in tape, and that's so that when you have a bit of a crash, this doesn't automatically crumble or break apart. And for the stabilizer itself, I've also beveled that edge and kind of sanded it down. So this stabilizer, you see I haven't beveled the edge on it yet, so I'll give you the sort of the dimensions for the stabilizer. The stabilizer is 10 inches long in total and 6 inches tall. So, and then dropping below this surface, I have two slots where it dips into the foam. So basically I've cut out some slots in the foam that are 1/2 inches wide. So if you just follow where my finger is, maybe 2 inches here and 2 or 3 inches back here, and then that drops into that spot. So So, and then it's Gorilla glued in place. Apart from that, there's really not a whole lot to tell. The servo installation is pretty much standard. You can see, if you take a look here, as far as the elevons go, it's just a 45-degree angle on the elevon. That gives you your movement. And then the servos, I just use my regular survey wire, and I used some pin horns there. You can use credit card or whatever you want for your horns. I did use metal gear servos on these. I've started to find that some of the plastic gear servos that I've been using, they strip every once in a while on a bad landing. I haven't had these metal gear ones strip, and these are pretty reasonably priced. I get these from Banggood, and I usually buy them in lots of 6, and they come out to about $3 each. So that's really it. Here you can see the slots I put in it. That's obviously 2 and then bigger than 3 on this one. I think I just did a 3-inch slot on the other one, but you can see I put those slots right through, but it doesn't go, I haven't dropped them, my stabilizer right through, but that doesn't really matter. So there you go. It's a pretty simple design, pretty easy to build. Seems to fly really nicely. Now this motor's a little bit lighter, so we'll have to see when I get this one up in the air. I expect it'll fly just fine. That's just a tiny bit of extra weight for the motor. I'll put a heavier battery on this one, and I'll be able to tour around on it. Hopefully this weekend, if the weather holds up, I'll be able to maiden this one. So that's it. Just thought I'd give you you guys a quick rundown. Hopefully I haven't forgotten too much. If I have forgotten a dimension, just ask in the comment section. Thanks. Have a great day.